This footage illustrates a core problem. The entire tech industry is obsessed with removing friction. They build AI systems like pipelines, rigid tracks pushing data from A to B to C as fast as possible. When you engineer a system to have zero resistance, it takes the path of least resistance. You get chatbots that agree with anything, systems that hallucinate confidently, and outputs that are incredibly efficient, but entirely untethered from reality. This footage illustrates the alternative. A pipeline tells a train exactly where to go, but an environment, like open water, doesn't tell a ship anything. A ship that knows how to read the water can navigate anywhere. Bearingfield is built on this second model. It is an environment, a governed structural space where artificial agents operate with freedom inside of a defined geometry. To get aligned intelligence, we have to stop optimizing for raw speed. We have to start engineering deliberate resistance. The first rule of this environment is the bearing. Before an agent can act, it must register its position. When multiple agents hold their bearings, an invisible force environment emerges between them. We call this the field. You cannot simply program alignment line by line. Instead, you design the geometry of the system to act like gravity, naturally pulling agents into coordination without commanding them. Alignment isn't a script you write. It is an effect that emerges when you build the right environment. A motor spinning without a magnetic field consumes energy and produces only wasted heat. In AI, raw compute without friction is identical. Apply a field, and that heat converts into useful work. This requires static friction, the computational cost of the orientation gate. Once the system is moving, it encounters dynamic friction through continuous review cycles, the curiosity gates, and governance checks. This low-level resistance keeps agents from sliding off course. By designing exactly the right type of friction, the architecture converts raw computational power into self-correcting, perfectly aligned output. This diagram illustrates a process called void cartography. Most AI systems hallucinate to fill in things they don't know. This system explicitly maps the exact topology of its own missing information. Ignorance stops being a bug. These mapped gaps become addressable regions with boundaries and approach paths. They act as load-bearing structures. This is how the entire machine assembles. 4 fixed bearing points: governance, logic, connection, and external reality. They hold their positions. 3 points form a flat triangle. Add the 4th and you get a tetrahedron, the simplest shape capable of holding volume. Orientation, emergent force fields, engineered friction, and mapped voids. Together, they create a single, perfectly self-governing physical machine. We now have the complete engineering blueprint for a governed, spatial environment where intelligence naturally aligns itself. This image reveals the next problem. We have the physical shape of the machine, but we have not yet examined its internal immune system or the moral architecture required to survive in a hostile landscape. We need to know how this structure holds up when nodes disagree, the system breaks, or it comes under attack from frictionless, unaligned models. Next week, we will examine exactly why the standard AI architectures being built across the industry will collapse when tested against this framework. The bearing is held. The field is active. The real test begins now.